Okay, perfect. Good evening, good afternoon, good morning, guys. Depending on which part are you connected from, welcome to all of you to this new GeoMax Academy webinar. Today with me two special guests for this for the today argument, Jennifer Busser, product manager for connection services in Novatel, Manfred Fussi, product manager for GNSS and total station in GeoMax. Welcome to all of you. I'm Francesco Zuccari. I'm the responsible for GeoMax Academy and the GeoMax support. So today the webinar, the main argument is the Ppp service and the Terrastar service from Novatel. Welcome, Jennifer. Welcome, Manfred.
Thank you for having us.
Hello, thank you.
Thanks, guys. So I think we can immediately start, guys. We have a very rich agenda today. We will have all the information about the Ppp service, about the Terrastar technology. Thanks to Jennifer. We will have an overview about the GeoMax GNSS receivers that can use this kind of technology, and for sure we will see also how to use it with our field software XPAD Ultimate. So the stage is yours, Jennifer. Please go ahead. Thanks.
Perfect. I will share my screen. Hopefully I picked the right one.
Take your time, Jennifer.
Can you see the presentation?
Yes.
Perfect.
Thanks.
Wonderful. So yeah, that was a great introduction. Today I'm going to be talking about our Terrastar C Pro with, correction service, which is a global Ppp corrections technology. In January of this year, we released a major enhancement to the service, which greatly reduced the convergence time down to as fast as 3 minutes, which has been a huge game changer, not only for our portfolio, but what people are now understanding is possible with this type of technology. So today, there we go. I'm going to talk about the enhancements to this technology, some of the background information for what the enhancements were, what our engineering teams have been working on, as well as what this means for end users in the field and just the evolution of this technology and how it's opening it up to more applications. With our RTK from the Sky technology program, this is the program that we're using to drive forward and push our global Ppp technology to provide an RTK-like experience, but through delivery methods like L-band that we use for Ppp. So that's why we call it RTK from the Sky, and we're constantly evolving and putting energy into this technology to drive to that experience. So I'll be talking about the convergence performance, the type of accuracy you can expect, the benefits of having this type of global technology as part of your application, as well as how this technology has become more robust with all of these enhancements. Okay, so before we dive in, a bit about why you would need corrected positioning to begin with and how you choose your correction source. So for many applications, you need real-time high accuracy positioning. This means that you need to know your location down to a very small measurement. So typically we say this is the centimeter level, and you need to get this positioning in real time. So it's not just a matter of collecting data and post-processing it afterwards in the office. This is about getting reliable constant positioning in the field when you're doing your job. High quality corrections also allow for repeatability. So whether it's the same day coming back to that same position, coming back tomorrow, next week, the next season, or next year, being able to have a repeatable position. Now, RTK and Ppp can achieve both of these things for you. So they're great choices for high accuracy applications. But it can depend on your project needs and where you're operating and the type of flexibility or requirements you may have that changes which correction source is perhaps best for you, or maybe having a combination of both that fits best with your application. So some things that people typically consider is where they're operating. Do they have access to these different correction types? How much flexibility do you need? Are you moving around a lot to different project areas? Are you working in a remote location? And some of these are the benefits that we can see with global PPP technology. So our Terrastar ecosystem, there's a lot of components to it. And so to understand the advancements that we have, I just want to walk you through this diagram on the right here. So our global network is basically a bunch of reference stations around the world. It's a sparse network, which means we don't have that many stations because this technology doesn't rely on having stations very close together. What we're most concerned about is having global coverage, because what these reference stations do for us is collect large amounts of data. So observing all of the constellations and satellites in the sky, collecting that data, and then pushing that to a central processing server where we model and all these different error sources and generate corrections. These corrections are then broadcasted through what we call L-band satellites. These are geostationary satellites, so they broadcast over the same area of the Earth, and they broadcast these corrections down to receivers on the ground. And what a receiver needs, well, it needs to be able to track constellations, track these satellites. It also needs to be able to track the L-band satellites, and it needs to have a Terrastar subscription just to be able to decode the corrections that we're sending over air. And then the receiver uses this data in real time to compute its position. One thing that we are really proud about with our Terrastar ecosystem is the high level of availability. And this is through a large number of redundant things that we have across the system to ensure that if one component breaks down or there's an interruption or an event happens that's sometimes even out of our control, we have all these backup layers to ensure that we're always able to collect this data, always able to compute corrections and send it over the air. So this has led to 5 nines of global availability, which means corrections are always streaming and you don't have to worry about correction outages wherever you go.
That's nice, Jennifer. We are starting to receive some questions. I'm glad about it. Just because I forgot to tell to our participant that you can participate actively to this discussion, sending us some questions. You have the box on the windows that you can use it to send us questions. Some of questions are already coming. So one is in particular on this slide. This is the reason why, Jennifer. So it's about how many satellites you have in orbit to stream the Terrastar signal.
There are 5 L-band satellites and they cover around the entire Earth. And so there's overlap from these broadcast areas. And since they're geostationary satellites, they don't move. So that same, where you're operating, you will always view the same L-band satellites. And typically there's 2 in view, depending on where you are, because they do have this overlap.
Okay, great. Thanks, Jennifer.
Perfect. So a couple of benefits of a global technology, and you can use global PPP either as an independent solution or layering it with if you already are using RTK, you can layer these 2 solutions together. And so I want to speak to some of the benefits of why global corrections can be useful and the benefits that we have from this technology. So first is that availability piece that I just spoke to. Corrections are always streaming. There's no data outages and things like that. You don't have to worry about moving out of range of a base station and dropping your connection to it. The solution is highly accurate. So we get 2.5 centimeters level accuracy horizontal. And this is a highly repeatable position. So you can come back and there's complex algorithms that make sure that you can come back and the receiver is adjusting for that. And then it's a highly efficient and scalable solution. And so I think this is one of the biggest benefits of a global correction source is that it's one single data stream, no matter where you are, and one subscription. And so you don't have to worry about sourcing different RTK or other source of corrections. You don't have to worry about if you're moving outside of the coverage region or if you've moved too far away from your base station. These corrections are always available and are easy to use wherever you're going. You don't have to have additional equipment. You don't have to maintain a base station. You just need that receiver that's capable of tracking L-band satellites, and you're good to go with corrections. So when we talk about now actually the enhancements that we've seen, I want to point out the diagram on the right. So this is an illustration to really show that step change we have now in performance. We went from about 15 to 18 minutes convergence time in the past, and now with these enhancements, we see convergence in as fast as 3 minutes. And this is a total change to how global PPP technology works. I think historically people have thought about PPP as a slower technology, which was true in the past, but this is drastically changing now. And these advancements in convergence time means the technology is perhaps more accessible to different use cases that previously wouldn't have been interested because of the wait time you needed from convergence. So in the next few slides, I'm going to talk about some of the technology that has allowed us to do this. The first is some end-to-end system improvements. So when you think about that diagram I just showed, areas of work in all of these components. And then one major contributor has been additional and modernized GNSS signals and how we've been able to leverage that in our corrections. And one thing that I think that is really interesting to think about is when you're working at this level of accuracy and trying to get convergence to be such a small value, you need to be addressing all these different error sources. And so it's been phenomenal to watch our engineering and research teams, the depth that they've gone into to understand all of these error sources and how to address each of them. It really is incredible technology. So just to give you a sense of where global PPP falls, and I'll talk about some of these corrections, is when we're talking about high accuracy positioning, we're usually talking about PPP and RTK, and that's that bottom line in green. And this allows you to go from an uncorrected position of about 10 meters down to something at the centimeter level. So Terrastar C Pro, like I said, it's a global technology. There's no baseline, and we're at that 2.5 centimeter mark. RTK, same accuracy level, but because of the differences in how corrections are computed, it's a local solution. So if you move away from your base station, you begin to get a degraded position. And this is why you see that slant with RTK. So it's interesting to think about how you can combine these two correction technologies to leverage the benefits of each. So the reason why I wanted to talk about comparing RTK and PPP there is because there are some fundamental differences to how corrections are generated. So corrections themselves, there's, I will say, two major groups. The first are global corrections, and these are for any user around the world. These are corrections that you need to adjust for. And these are typically to do with the satellite error in space. And when you think about positioning, it's all based on geometry. And when you have satellites in space, the better that you know the position of that satellite, the more accurate and better you know your position on the ground. So by adjusting for any errors or unknown values for that satellite position, we can then adjust our own position as well. So this has to do with the satellite motion in space, the clock error on board, and any other biases to do with the orientation of that receiver in space. And this is global PPP really addresses these types of corrections. Then there's regional corrections, which are more local, and this has to do with the atmospheric effects. So as that satellite signal travels through space, it enters our atmosphere. It gets sometimes interference because of the particles in our atmosphere. And these are highly local because the atmosphere and the weather conditions all around the world are a bit different. And so this is where there's some benefits to RTK because you can really understand that local condition. Now, both technologies do have a convergence time. The difference is that RTK's convergence time is so fast that we don't really notice it. But with PPP, we need that remaining convergence time to model the remaining errors at the receiver. So most notably those atmospheric errors. And so being able, the higher quality that you have for your corrections, the more information your receiver has, the less time it typically takes for you to converge. And this is kind of a high level summary of what we've been working on. One major difference as well is that RTK, it groups all the corrections together, and you don't really understand, or you don't have to model each individual correction. Whereas with PPP, this is what we call a state space representation. So we are estimating and modeling each individual error state, and this is what we use as corrections. And so we've been working on the satellite orbit, clock, and bias errors, and using more information to improve the quality of those corrections. So there's many things that go into, do you have a question?
Yes. Yes, we
Okay.
got another very interesting question that honestly
Sure.
is something that also I would like to know, because Jennifer, first of all, I can see that you are really proud about the changes, the improvement you had in this service. And honestly, I tested the PPP, so with the previous, let me call it previous version, and now the change is mind blowing. Believe me. It's incredible. So this improvement to get the position from 18 to 3 minutes in the best case. So we are talking about 5 minutes in the average to get the fix and the centimeter accuracy has been achieved using new satellites or new algorithms. Or what is the recipe?
It's a very complicated recipe. And I think there's two main areas. Well, I shouldn't say two, but really it's the new signals. And I have a slide that I can talk to more in detail about that. But GNSS positioning, we rely on the GNSS constellations that are in space and what these different GNSS organizations, how they're modernizing their own constellations. And so being able to leverage that amount of information. And then also, because we deal with generating the corrections and developing the positioning algorithms on the receiver, we can fine tune these things to work very closely in sync. So that's a perfect actually lead into these slides, because I wanted to speak to a bit some of the areas that we can look at in combination of the corrections and the algorithms and how we can tune these two things together. So we have the network and rover algorithms. So making sure that we have the best positioning, not only on the rover, but also the algorithms on our reference stations to be getting the highest quality correction or observations in, because the quality of those observations directly goes into the quality of our corrections as well. So the reference station quality is not just the algorithms, but it's the location of our reference stations, making sure if we need to add one or replace, update antennas, just making sure that they're at the top quality. And multipath sensitivity, multipath is always going to be a factor, maybe, for GNSS, but reducing the sensitivity to that, both at our reference stations and as well as at the receiver. And then the satellite availability, so how well we're able to track these satellites, how many are in view. So there's many layers to this. It's not just one simple thing that has helped us to improve convergence time. And if you look at this graph on the left, you can see, back in 2011, we were at about 45-minute convergence. And I think that's historically where people kind of still picture global PPP at. But in 2016, we got that down to 15 to 18 minutes. And this is just due to all of these different factors and having continued advancements in all of these areas. And then, of course, today we're down to as fast as 3 minutes.
Wow.
So a bit more, I'm not done yet on this topic, a bit more on the satellites themselves and the signals that we have available. This has been a major contributor to these improvements. And that's because each satellite in space is broadcasting multiple signals. And so the more information or the more signals we can track from each satellite, the more information we know about that satellite and the better corrections that we can compute for it. And so we've seen across these different constellations some improvements and modernizations. So there's more GPS satellites with a third signal called L5. Galileo has continued to expand their constellation, and they've reached or perhaps surpassed 26 satellites. And the Beidou constellation has continued forward with their phase 3, which has signals on 4 frequencies. So previously we were working with dual frequency technology, and so by tracking and using triple and quad frequency signals, this provides us more information about those satellites. Does that answer your question?
Yes.
Okay.
But now the next question is obviously about the repeatability of the measurement.
Yes.
So some of our participants are already asking about it. Let me try to ask and to explain what they want to know. So if a customer use the PPP, okay, and today start to work with the PPP in a location, okay. So what about when the customer return in the same position after a year? Do he need to recalculate the adjustment? It will find a shift in the coordinates.
Yeah.
What?
This is an interesting one, and again, there's a lot of science behind it. And so when you compare RTK and PPP, RTK is that local solution. It's on a plate. It's a plate reference system, basically. And so you don't have to worry about shifts necessarily in tectonic plates and things like that, because everything is stable and moving together. Whereas with PPP, it's a different reference system, and so it's an Earth-centered system. So if there are shifts in those plates, you need to be able to adjust to it. And I think this is to what you're asking about. And so we do have, this is where it's not just the corrections, it's also the quality of the algorithms. So we have algorithms in place that a user can enter in the date that they want to fix back to, or the epoch, and they can basically rewind their real-time coordinates back into that frame. And so if you come back a year later or 2 years later, you can interact with the firmware, put in this information to adjust your reference point so that you're measuring at in that same frame as you were before. So this is just one example how the algorithms and corrections work very closely together to provide that kind of experience.
Well,
yeah, it's pretty cool.
Yes, it is. One thing, Manfred, because I know that also you are a very expert in network correction, RTK, and all these kind of stuffs. So speechless.
No, not speechless, but muted. Yes, it's as always. There's some kind of best practice how to work with these technologies. So here you need to care about of course, signals you are tracking and how you operate your rover and stuff. But as mentioned, about the reference frames, and that's clear. There is areas where basically nothing happens. Slow tectonic movements, no big changes over time. And there are some areas with high tectonic movements and high changes over short distances from where you have derived your recent adjustment, or not only distances, but also in time. So a couple of months could make a difference, which is not acceptable anymore for the accuracy you might need for your job.
Yeah. And if you're using both PPP and RTK at the same time, there are also ways to make sure that you're operating in the same datum and being able to do a datum transformation with the PPP correction so that your PPP output is also in that if you're using both correction
Manfred,
sources.
no, it's me.
Oh, did we have an audio issue?
Oh, Francesco.
Was my connection. I had an audio issue.
Was me.
Sorry, guys.
Yeah, but
okay, sorry, guys.
With our firmware, we compensate for, we can work with all of these different datums. We have people who are highly trained and educated and have done all of their education in this area, and so they're experts and make sure that everything is lined up properly. Okay, I'm going to move to the next slide.
Yeah.
So now I want to show some actual data sets for what this looks like. So when we did the enhancements, now we're seeing convergence time in as fast as 3 minutes, and we are seeing this fairly consistently around the world. On the right, this is what actually happens when you turn on the receiver. So this is just a single convergence curve. This is quite a typical way to show PPP convergence time. So you have that position error over time. And so we're looking at how quickly that curve comes down to your accuracy level at 2.5 centimeters. And so you can see that we hit that within a couple of minutes. And then on the left, you can see we use 68% statistic to capture the typical behavior of convergence time. And again, we're hovering around that 3-minute mark at all of these locations around the world. Now, Ppp Technology, if you think back a few slides ago when I was talking about why we have convergence time and it's measuring those remaining errors, there can be variability in that convergence time depending on the conditions you're tracking in, the type of hardware you have, the visibility that you have to all the satellites. And so there is variability in that convergence time depending on how quickly your receiver can resolve those remaining errors. But what I wanted to point out is that no matter where you are and what you're operating at before, so this is the blue line in this case, we're seeing significant improvements to convergence time. So even within that natural variability of convergence time, all of the solutions have been improved by at least, on average 60% improvements. And so this is a noticeable change that users, regardless of your configurations previously, you will still see and experience these improvements. Okay, and now this is one of, I think, the most interesting outcomes of all these enhancements as well. We spend a lot of time focusing on just the initial convergence time and all the improvements there. But actually, the enhancements that I've spoken about, all these different areas, have also led to more robust positioning. And what I mean by this is the ability to maintain your position in challenging environments or to recover quickly after an outage. And so with this fast initial convergence time, we're seeing similar behavior with reconvergence as well. So this is one data set that we collected through an urban environment across city highways and through residential areas. So you can picture there's trees, signs, perhaps bridges and things like that. And on the right, you can see where we have these spikes, these quick spikes. That's where we typically have passed underneath an obstruction or something like that. Now, the green line is the previous performance. It's not bad, it typically remains within a meter, which for many applications that wouldn't be good enough, and it starts to drift off. But with the new enhancements, we see that that blue line snaps right back down. So any GNSS technology will have challenges if you have an obstructed environment. And so when we talk about robustness, it's how much is that impacting your error and how quickly can you recover. And so you can see that blue line recovers very quickly, within tens of seconds, sometimes instantly, even when it didn't have a chance to recover well. So that green line continues to drift off because we continue to challenge it, go through difficult locations, but the blue line, it was good. It snapped back down even though we were still putting it through challenges. So this means you can use this PPP technology in even more places than before. So the combination of the improved convergence time and the more robust positioning means that it's more accessible for different use cases. Okay, so that's the end of most of my content. So just kind of a quick summary. We have, with our new Terrastar C Pro enhancements, you get that same real-time performance at the highest accuracy levels, but now faster than ever before. With the global coverage, this has different benefits that you can help to layer with an existing solution or use independently. It's a very simple correction source to integrate into your solution, and there's no boundaries and borders to be concerned about. There's also no additional infrastructure cost. You don't need additional base stations or cellular modems. You just take your receiver and go. Highly available, highly reliable correction source. And there are a variety of subscription links to match your needs that you can access through your dealer. to match to the length of your project. So yeah, I think that's all of my content. There's a lot of information to squeeze in, but I hope it's a good summary of all the technology and some of the benefits.
So very clear and very impressive, Jennifer. Thank you very much.
Thank
really.
you.
And Manfred, on our side, so how we can use this service, the Terrastar service?
Okay, I mean, of course, as Jennifer pointed out already, in general, network RTK would be the preferred way to go for the precise measurements. That's the most easy one. That's widely accessible and provides super fast and accurate positioning. However, the problem here is that you are not always in an area which is covered by an RTK network. And then you could start setting up your own base station. That means you would need a second receiver, that you would need to set up communication channel, mainly UHF radio, where you need the radios itself, where you need to have, maybe you need to have to apply for frequencies which you are allowed to use and so on. So there's quite some investment in both costs and effort, and it provides you only a limited range, as we also have learned before. But in some cases, this might be an option. In general, these Terrastar corrections are available basically globally. As soon as you can track the L-band signal, you can make use of these corrections. That's great. That's easily accessible. There's not much to do. You no need to invest in additional hardware or in setting it up. Sometimes it's even, let's say, a little bit dangerous to set up an unobserved base somewhere. We had cases that those hardware has been gone eventually because of people are stealing it. But anyhow, with the Terrastar services, you're good to go. And when it comes to some kind of connectivity issues, also in areas where you would have an RTK network or a base station, it might be very unlikely for the Hexagon smart nets. Of course, there might be some downtime in the network. And also you might suffer from outages of the mobile internet connection. So there's no way to receive any, let's say, regional corrections there. And when it comes to the GeoMax hardware itself, we have this GeoMax Zenit 40 receiver, where current users can also benefit from this improved Terrastar C services. And the Zenit 60 receiver with IMU and tilt capabilities. So if you ensure that both hardware devices run on the latest and greatest software, and that you have the recent and updated Terrastar activation for the C Pro service, then you're good to go.
That's perfect. Okay. So in this case, I think it's now it's my turn to show you something. So let's start immediately with just a second that I set up my my screen. Okay. Okay. Sorry, guys. Okay. Let me see if you can. I think you cannot see anything.
Yeah, we can see you,
Yes.
your screen. We can see XPath.
Okay, okay, perfect. I cannot see the image. Okay. Because I cannot see the image on my monitor, but anyway, this is so with my receiver and my XPAD Ultimate that is working. This is the office in Rome. PPP that it's absolutely a very nice accuracy. But anyway, I would like to show you the way how to work with XPAD Ultimate and the PPP. So first of all, XPAD Ultimate working with the Zenith 40 or the Zenith 60 give you the possibility to mix the two technology. It means that I can go directly in the settings. Like in this case, I select GNSS and total station. Right now, I was connected with my Zenith 60, and I will show you the configuration that in this case allows to me to work not only with the network, the RTK network, but also with the PPP correction. What does it mean? Basically, I can easily use it, use the PPP correction as a backup of my RTK correction in the case where I'm going to work in an area where is not well connected by the mobile phone provider. So in case I lost my GPRS, my modem connection, I can use the PPP. And how to do it is the software that will manage this kind of connection, switching automatically between the two of them. So obviously, I need to configure my RTK provider. That here it's Italpos. I have my full configuration for the receiver. I don't need to configure my receiver because it's already configured with this setup. Once I select or I create a new job, for example, this one, I will call it webinar PPP. Okay, and so accepting the position that it's here in Rome. So once I select to go and survey the points, the software is connecting to the receiver and is analyzing the configuration that I have created. So it's starting immediately asking me if I want to use the PPP mode because it was set up in the correction. Yes. For this reason is opening the PPP manager. In the PPP manager, I have my PPP position adjustment files. It means that obviously I need to work with both systems simultaneously. I need to create an adjustment between the RTK position and the PPP coordinates. So I can select an existing adjustment file, or I can create a new one. Let's go quickly to create a new one, just because it's a very quick procedure. I need to get 30 seconds of RTK data. In this case, is reading the position from the RTK network. It need just to get 30 seconds of position, and then right after I can select how many minutes I want to read the same position with the PPP service. So this is those are my position, the quality that I want to achieve with the PPP network. Just to be quick for the webinar, I will use and some high values, even if so the PPP it's much more accurate in this area. Right now, the receiver, what the software did, has closed the RTK correction, is tracking the PPP satellites, and now is getting immediately this accuracy that is 7 centimeters horizontally, and so it jumped so quickly to a very nice accuracy. Obviously, I selected 1 minute to stay 1 minute in the same point to match the two coordinates. So just 60 seconds. After the 60 seconds, we will see the shift values on latitude, longitude, and elevation. So these kind of values are suggested to be used for a maximum around 50 kilometers distance from the first calculation, and more or less about 2 months validity. By the way, this is a suggestion. I can still use a convergence set, so the adjustment it's already calculated. I can accept it. So I can give a name for this adjustment, and basically it's done. We are using, in this case, we are using the RTK, so we are using the local network. I create the local coordinate here, and now I will play a bit with accuracy. I will disconnect the GPRS. So I remember to you that I measured the point using the Italpos network. Right now, I closed the correction, and I can see that the age of the last correction received from Italpos is increasing. Right now, after a while, the system will switch like this immediately, is switched automatically to the PPP service. So what I did is to simulate that I lost the connection with Italpos, and automatically the software jumped to use the PPP. So right now I measure the point M1. Let's try to stake out the point with the PPP, and as you can see, the quality is absolutely so amazing. It's 1 centimeter horizontal and 3 centimeter vertical. So this means that immediately the software is able to give me the possibility to continue to work even if my connection with the local network is down. What can I say in addition? For me, it's really an amazing service. So obviously, I can work with these two different correction simultaneously, like the example we did it, or I can use only the PPP service, and in this case, using only the PPP, I don't need to calculate the localization, and I will be faster during the job. So switching to the satellites information, this is what is the very easy workflow with XPAD Ultimate. So this is also more or less everything. Also from my side, I think that we can turn to the question and answer session. Let me, okay, just a second. Okay, guys, can you hear me? Because I cannot hear.
And we can see your screen as well.
Okay. Can you please help me to understand which screen you can see, because it's
we see it says first activation. It's a PowerPoint screen.
Okay, it's the PowerPoint screen. Okay. Yes, this was exactly the PowerPoint, but I decided to show you how the software work in real time. So, okay, let me. Okay, so jumping to the question and answer, guys, we received some additional questions from our participant. First one, and very easy. In which coordinate reference system are the Terrastar correction provided?
It's in ITRF 2014.
Okay.
So it's a global Earth-centered Earth fix. So it's based on the system of the Earth.
Okay, good. The second one, it's a bit more technical. It's about how to activate the license. So I think this is very interesting, but maybe the other one, it's even better. It's what about if I want to test the PPP with my receiver?
Yeah, I can answer both of those together. So we have demo licenses for free for your first 5 days of the service, and you can access that through your dealer. They can request that through the e-store. And basically you take the part number of your receiver, we apply a subscription to that, and we send an activation message over the air. So same way as the corrections are delivered, the activation message is sent over the L-band satellite signals. And so it's very easy. You just have your receiver on and tracking, and it receives that activation over the air, and then you're set and ready to go.
Okay, that's great. That's great. And so, and after the purchase, how can they activate the license on the receiver?
Yeah, so it's through that L-band delivery mechanism. And so if you miss your first activation message when it gets sent over the air when you're tracking L-band, it's easy to request it again. So if you didn't have your receiver on and tracking at the time, it's no problem. You can request through our system again to just resend the message, and when you're ready, when you're set up and to track it.
Okay. Yes, basically, even on the software is needed just to place the receiver outside with a clear in an open area to start to track the satellites, and
yes.
After that you can see the receiver that show to you the PPP available. So, for example, on the software, in this case, on XPAD software, just pressing the battery the battery icon, you can see the PPP license if it's available, and until when the license is available. For example, this is temporary license thanks to Jennifer that has provided to me this license for the test, and it will be available up to the 29th of June. So as Jennifer said, it's available for all the receivers, Zenith 40 and 60, GeoMax. The demo license valid 5 days to test this technology directly by you in the field. So let's go ahead with the questions. Is there any restriction for the system? So we are talking about the Terrastar C Pro license.
Yeah. So I believe the license that's being used on this GeoMax equipment, it is global. So you have access to all L-band satellites, and it is land geo-gated because it's primarily being used for land applications. Then you have access to corrections from 20 kilometers from the shoreline, 10 to 20 kilometers depending on where the shoreline is. And so that provides maximum coverage, and if you're operating close to water, you still will get some coverage. So it's not a super tight geo-gate. So yeah, there's very few restrictions. As long as you're operating on land, you're good to go. Okay,
and Jennifer, another question regarding the infrastructure. How many base reference stations there are in the world?
I think we're around 100 now, which is quite a bit, and they're all kind of distributed around the world, and we check on them routinely and make sure that everything's working, and we have a monitoring system that's making sure that they're all up and running. And so at times we look at expanding the network in some places and filling them in, but it's a pretty constant, stable network.
Okay. Good, 100. Wow, really a lot. So can I use it in combination with N-Trip RTK? So in this case, I think that with the demo, I already replied to this question. Yes, for sure, you can use it in combination with a RTK network. What you need to take care is to calculate so the right coordinate to work with both. Are correction from satellite broadcasted from dedicated satellites? Yeah, sure. If yes, what happens if I do not track any of these satellites? So that's a nice question, Jennifer.
So if you lose sight of one of these satellites, it's just as if you lost visibility to your GNSS signals as well. And so this would be considered an obstruction. And so when you lose corrections, then your position quality can start to degrade. Similarly, if you lost your RTK corrections, your accuracy would also begin to degrade. But if you think back to one of those slides I had before where I talked about how PPP, we measure each state or we model each correction type independently. And what this means is that the receiver knows a bit more about which corrections are valid. And so if you lose your correction source, it's actually able to leverage some of this information in the background and reduce the impact, and you maintain your accuracy for a bit longer. And so you don't see that position degradation as quickly as if you lost RTK corrections. So that is one nice benefit of PPP corrections, is that the receiver is able to hold on to your position a bit longer. Hopefully you get your L-band satellite back, you come back into visibility, and you can get corrections again.
Wow. Okay, good. So even more technical, so it's partially already replied by you. If I lose several satellite signals, for example, walking under canopies, and lose the fix, Has the system to converge again waiting the 3 minutes, or will be faster?
It depends on the severity of the outage, but in this situation, it sounds like a partial outage or under some trees. It would converge faster than the initial convergence because it still has visibility to some satellites. It still has that correction data from before. So I just talked about how it can use some of that information in the background if you've lost your corrections. And so typically the reconvergence is faster than the original convergence. And sometimes it's instant, like once you get that good visibility again, you're back down to your position accuracy. So it can range. It depends on the severity, but it's definitely more robust with this update.
Okay, good. And so another question about the convergence. Has the receiver to be steady while converging, or can be done also working?
There's no requirements. You can be static or you can be moving. Either case, you can converge. Sometimes though, actually moving can help with convergence. If let's say you're close to a building and you have multipath nearby, if you move, it allows the system to recognize that there could be some multipath in the area, and it allows the observations. That movement helps with that initial convergence and getting your position. And so you don't have to be moving, but if you're in a more challenging environment, sometimes that can actually be helpful.
Okay, that's great. That's great. Okay, so some of the question, guys, are about also the cost of the service, but in this case, so the best reply is to talk about with your local dealer to understand also, and to be helped also to test the service with your receivers. Manfred, thanks to your team, we had also a new firmware release for our receivers right in the past few days. Thanks a lot with this firmware. So now all of our customers are able to use this service. So guys, we are exactly on time. That's perfect, right? 1 minute before the expected end of the webinar. So before to thank you for the participation, I would like to ask you if you want to suggest something in particular to our participant today.
I mean, I'd say try the technology yourself. I think it's really exciting to see the changes and advances that we're having. And so if you've had experiences with PPP before, it's completely changing. And so it's a great time to try the new technology and see for yourself how it can fit with your applications.
Well, there's not much to add from my side. I fully agree. Just try it out. If you are not familiar yet with this service, you will be impressed for sure. And regardless of your decision, you might not need it because of you are lucky and you are in the area with good mobile internet and network coverage. But in any case, please ensure to update the receivers to the latest and greatest firmware, and also, of course, to the latest and greatest version of the expert field software in order to benefit from all the new features and stability and performance improvements.
Good. I cannot say anything better than you guys. I would like to thank you for your participation to this GeoMax Academy webinar. Thank you, Jennifer, for also for your help in the past weeks to prepare Everything. Thanks, Manfred, for your daily effort on on our hardware. So thanks also to all the participants for your participation to this webinar. So the video of the webinar will be also available later on the GeoMax webpage. In case you have additional questions, please send us to support@geomaxpositioning.com. Will be really a pleasure to reply to your questions. Even if you have additional questions to Jennifer and Manfred, will be a pleasure for me to forward your question to them. Please challenge a bit these two guys. And if you have also any kind of suggestion for a next webinar, any kind of request, challenge us. Will be a pleasure to organize the next webinar with your suggestion. Again, thanks a lot, Jennifer. Thanks a lot, Manfred. I hope to have you on our webinars soon.
Thank you for having us.
Thank you. Goodbye to all.
Thank you and bye-bye.
Bye.
Bye.